That one. All right. So here's y equals a log x. This is a base 10 log because you don't see any number there, right? Which will become more important today as we actually look at the log function. It goes from quadrant 4 to quadrant 1. It's increasing. If the a value increases, then the function increases at a greater rate. And if the a value goes negative, then we're going Q1 to Q4 decreasing, right? So that's really the gist of what you need to know from yesterday, right? Just how the a value affects it. And that's pretty easy to graph, right? And you could just graph y equals log x in your calculator and see that it goes from here to here, right? Say Q4 to Q1 increasing, and you could graph -2 log x and see that it goes the other way. And what holds for log also holds for ln, which is the natural log. So there's ln, same deal, still Q1 to Q4 with the a value, and the larger it gets, the greater the increase. And if a goes negative, then we're going Q1 to Q4 and it's decreasing. Use the ln key.
Where is it located?
Right below the log key.
Was that located?
So if you can find log,
I can.
you can find ln or ln.
You can do it.
Yeah. You need. Like, everybody showed up today? Wow. All right. Anyway. It's a page. Okay, so evaluating log expressions. So what is this logarithm thing, and how did it come to be, and how do we handle it, right? What do we do with that function? Which we know is sitting on our calculator, right? It's important. It's got its own key, right? It's like right up there with sine, cos, and tan. And with squaring, and not really square roots, but square roots is a second function key. It's a shifty thing. Okay, so let's say we just look at an exponential equation, right? That's an exponential equation, right? Last unit. Okay, keep in mind, I mean, the quiz tomorrow will have modeling exponential situations with, finance modeling. So it's like, here's the thing, run a regression, tell me about growth or depreciation, as well as more financial stuff with exponential equations. Compound interest and stuff like that. So the formula a equals p times 1 plus I to the n. And that's on the page, so the formula is given to you. Anyways, so we do y equals 10 to the power of x. And so we're going to do this for some values of x and y. And let's go -3, -2, -1, 0, 1, 2, 3. And just get some values. Okay, so what's 10 to the power 0? Let's start in the middle here. 1, right? Because anything to the power 0 is 1. What's 10 to the power of 1? We'll go with 10. What's 10 squared? 100. And what's 10 cubed? 1,000. Now we know that negative exponents just flip it, right? So when the exponent is -1, it becomes 1 over 10 to the 1, which is 1/10. And 1 over 10 squared, which is 1/100th, and 1 over 10 cubed, which is 1/1000. And if we graph that, it would have a typical graph of an exponential function. Starting out low here, going up. Right? This would have a value of 10. This would have a value of 1 when x is 0. We've got a 1. Okay, and watch for that, right? I mean, sometimes you're doing the questions, you're not reading them, right? It says, like, which quadrant is it going, and is it increasing or decreasing, right? So, read the whole thing and say, what goes in this blank here? All right, if we do the inverse function, to do an inverse function, we interchange x and y. So we'll get x is equal to 10 to the power y. to do an inverse function, you just take this table of x's and y's, and being as we interchanged x and y in writing this, we interchange the x and y here. So we say, okay, 10, well, so now that needs to be a negative 3. That's my exponent, and the value of x will be 1 over 1,000. 1/100th and negative 2, right? So we're just taking the table and, kind of flipping, right? Interchanging the x and y values. 1/10, -1, that'll be 0, a 1, a 2, and a 3, a 1, a 10, 100, and 1,000. Good. I can't do that. And if we look at the graph, we say, okay, when x is 1/1000th, that's like really, really close to this axis, right? We've got negative 3. So we're down here. When it's 1/100th, that's still really close. We're at negative 2. And then we're at 0, we're at 1. So we've got the graph of a log function, right? So really, the inverse of the exponential function is the logarithmic function, right? Just like square rooting is the inverse of squaring. You square something, you want to undo squaring, you take the square root. Okay? You want to undo raising something to an exponent, or say, what is the exponent? And that's really what the log function does, is tell you what the exponent is. So what we have is that x is equal to 10 to the power y is the same as, okay? We don't like that, right? We don't like writing functions or stuff so that it says x is equal to. We like to write it y equals. So we can translate this and it becomes y is equal to log x. Okay? And there's actually a base of 10, so we put the 10 down here. So we say y is equal to log base 10 of x. What happens if I don't write the 10 there? It's still base 10, right? So it's like doing square roots. We don't put a little 2 in for the index when we do a square root. We just say, you see this? That's a square root. You see this? That's a square root. You never see that. We don't put the 2 in there. So if you don't see a base down there, then the base is base 10, right? And it's the one you're just going to use on your calculator, right? So you just hit the log key. So if we look at this, we'll say, well, okay, what's y? I mean, it's 10 to the power. What do we call the thing up there? It's an exponent, right? So the y, this is just a different way of writing the same thing, right? So the y is the exponent. So the y is the exponent. The 10, what do we call the 10? The base, right? So the base of the exponential function, it's the thing that's being raised to the exponent, which is the value of y, or it's the base of the log. And then the x, that's what we get out. That's the value, right? So what happens when you go 10 to the power of? You get a value. So the x is the value. Okay, it's what you're going to end up with when you raise the base to the exponent. Okay, so we need to be able to translate back and forth between an exponential form and a logarithmic form. Okay, so that's what we're going to practice today. All right, so we are interested in y equals log x, which is read as y is equal to log base 10 of x. Okay, so if there's no base written, what's the base? 10. Okay, so if you don't see a 10 down there, then you just say it as 10, right? Log base 10. That's so common, it's called the common log, that we just say y equals log x. So if I write down y is equal to log base 10 of 100, Okay, what's y? What did we just say y was? We circled it and we said this is the exponent, right? It's the exponent that we raise the base. What's our base here? 10. So this translates to, I have a base of 10 and an exponent of y, and that's equal to the value 100, right? So 10 to some power is going to give me 100.
Oh my God, what you get? Thank you, son.
Feels like a book.
That is a book. It's a math book.
Oh, you don't want to lose that. Okay, so if I say 10 to the power of what is 100? What do you say?
17.
Okay, and if you want to be correct, you might say 2. Right? So looking at this is easy to solve, right? And we solved exponentially. So I'll just write this with the same base. So 10 to the y, I can write 100 as 10 squared. They have the same base, so we can then say y is equal to 2. Okay? You don't have to go through all of that, right? If you know that 10 squared, so you're looking at y equals log 10 of 100, and you say, okay, a logarithm is an exponent. Okay, so a logarithm. This thing is a logarithm, right? When you're evaluating, that's a logarithm. What is it? It's y. What's y? It's an exponent. So a logarithm is an exponent, right? You just got that fancy word. Okay, logarithm, right? And you don't know what's a log. So anybody asks you what's a logarithm, and you say it's an exponent. What exponent is it? Well, when it's written like this, it's the exponent that I raise this base to in order to get that value. So when I look at this, I say 10 to the what is 100, and then I come up with 2 pretty quickly, right? And I say 10 squared, so then the y value is 2. Okay, what if we do this? Y is equal to log base 10. Okay, so I'm going to write the base in just for the heck of it, right? I mean, just so we see that. Y is equal to log base 10 of, oh wait, let's change that. That's too easy. There, 10,000. So what you want to say to yourself is 10 to the power of what is 10,000, right? That's how you read this. 10 to the power of something, question mark, what, put in there whatever you want, like 10 to the power of what is 10,000. Okay, so what's the answer? Use your fingers. 10, 100, 1,000.
21.
4, 10,000, right? Yeah. Tough stuff, this. Okay, so we say then y, which is the exponent. What exponent? It's the exponent we raise the base 10 to in order to get the number 10,000. So y is equal to 4. All right, what if I said this? Okay, I'm not really saying this, I'm writing this. What if I wrote this? Then what do you need? 10 to the power of what is going to give you 500? At this point, you're sort of like, wait a sec. Like, I could do 10 to the power of what gives me 100, because I know that's 10 squared. I could do 10 to the power of what gives me 10,000, because that's 10 to the 4th. All that I can tell you is it's somewhere between 2 and 3, right? Because 10 to the 2 gives me 100, and 10 cubed gives me 1,000. So that value has to be between 2 and 3, but I don't know what it is offhand. Okay? So we will look at how to work that out. Okay? And all you do is you use your log key, right? Sorry, let's go back. What is it? So hit the log key and then go 500.
2.698.
2.6989?
89.
So let's call it 2.70 then? It's rounded to the nearest hundredth, 2.70. Okay, now you can check that by going to your calculator and go 10 to the power of, using that upside down V, which is called a caret. So go 10 to the power of 2.7, hit enter. You can get exactly 500?
501.
501. You're going to be close though, right? So the more decimal places we have, the closer we're going to get to the actual value. If you went log 500 and then went 10 to the power of second function answer, you'll get back out exactly 500, right? Because you'll be putting in that exact number to like 8 or 10 decimal places. Okay, try this one. So what are we going to do with that? What's the answer? You should be just going to look at that. What's the answer? Okay, so this is what you want to do then, right? You want to say, all right, I am given an expression in log form. What's my base? 2. What's the exponent that I'm raising the base 2 to? Y. And what value do I get when I take 2 to the power of y? 8. Okay, any answers yet? Y equals 3, right? So now to solve this algebraically, you could go 2 to the y is equal to, and we could write 8 as a power of 2, right? So 8 is 2 cubed. At which point, when the bases are the same, we can drop the bases and write the exponents. And we just say y is equal to 3. Okay, y is equal to log base 2 of 1/8. What's the answer? All right, so you should start off by saying, I'm not sure, right? So let's change it, because log form is hard, right? Got the word log in there. I want to have a form that doesn't have words, just, you know. So it's 2 to the power of, so 2, the base, to the power of, is equal to 1/8. All right, good, right? There's no more log in there. It's just 2 to the something. All right, well, 8 can be expressed as 2 cubed, so that's 1 over 2 cubed. And 1 over 2 cubed can be written as 2 to the power of -3. And so y is equal to -3. Do you want to check that? So if you're looking at this, you say, I think it's -3. Then you go 2 to the power of -3. And then you go math, enter to change that decimal, because it's going to give you 0.125. You go math, enter, it'll change that into 1 over 8. And then you go, got that one right. All right, yeah, don't worry, it's big writing. A lot of pages, but it's big writing. Y equals log base 1/3. Of 27. Okay, and we kind of know what that graph looks like. I'm not going to make you responsible for a base that's 1/3, but we can write this in exponential form. So what's the base? 1/3 to the power of. So 1/3 to the power of y is equal to 27. Okay, 1/3 is 3 to the -1. 27 is 3 cubed. Okay, we'll learn how to do this on a calculator too, but in the meantime, it's good to just get used to manipulating these. It'll come in handy. So 3 to the -1 to the y, what's that equal to? 3 to the -y. Power to a power says you got to multiply -1 times y. So 3 to the -y is equal to 3 cubed. Bases are the same, so now we equate the exponents. So -y is equal to 3. So what's y? -3. So on your calculator, if you go 1/3 to the -3 and hit enter, you're going to get 27. So that's a way for you to check, right? A lot of stuff that you have the ability to check stuff over when you look at the forms. Okay, changing exponential to logarithmic. So changing exponential form to logarithmic. So exponential, I'm going to give you 3 squared is equal to 9. Okay, that's no big deal. Nice, easy, true statement. 3 squared is 9. Okay, we want to write this in logarithmic form. Okay, so I'm going to write log. What's the base? So the log base 3. What value do we end up with? 9. So log base 3 of 9 is equal to 2. What's a logarithm? It's an exponent, right? So logarithm, so log base 3 of 9 is the exponent we raise 3 to get 9. Okay, now we don't have to figure that out because it's there. We say 3 squared equals 9. But we could say stuff like, all right, so 81 is equal to 10 to the power of y. I want you to write that in logarithmic form. Okay, so give it a shot. So I'm going to put down the word log. You want the base. Base 10. You don't really have to write that, because if you don't write that, we're just going to assume it's a 10. Log base 10. What value do we end up with? And what's the exponent that we raise the base 10 to in order to get 81? Y. So you could write it y equals log base 10, 81, or you could write log base 10, 81 equals y, right? Doesn't matter what order it comes in. All right, does that make sense? We got this exponential form, right? The base is 10. The exponent is y. What's a logarithm? It's an exponent, right? What exponent? It's the exponent that we raise the base 10 to get the number 81. What is that? Well, we could work it out. We need a calculator, right? It's between 1 and 2, because 10 to the 1 is 10, 10 squared is 100. It's closer to 2 than it is to 1. Okay? I don't care what it is. It's not important. Now, we got one other base that we deal with. The base E. If you want to do a log base E, so I ask you, what's the base? So you say, okay, the base is E. So what do I write? Well, you could write y, because that's the exponent, right, is equal to the log base E. So instead of a 10, we just use E, right? It's that magic number. So y is equal to log base E of 50, right? So the value 50. Now, another way we can write that is, instead of log base E, we write ln. Very important function, got its own key right below the log key and above the store key. So generally we're not going to do log base E, we're going to do ln. Okay? So we can use ln. I don't think you're going to see it on the diploma, and I might put the odd question with that in there. If you go on post-secondary and you do especially any sciences, biology or finance or stuff like that, you're going to see log base E or ln. Right? And the important thing is you just remember that, okay, it's one of those logs. What's a log? It's an exponent. Okay, if I see ln, it's using that number E, whatever it is, right? But there's an E key on your calculator. The second function of the ln is E. Yep.
Is there a way to change like the log base in your calculator?
There might be. What have you got? 83? Now you're good. Yeah, there is a way, but you can't do it in the calculator. Okay? But there are questions written, it's called the change of base, right? It's like, okay, look, my calculator does two things. It does base 10, does base E. What if I want to do a base 3 log? How do I do that? Okay, there's a formula on the formula sheet that shows you how to change it to base 3. And I have written questions for exams, I just wrote one for the field test, where you have to be able to do a change of base. Now the newer calculators, the 84s and up, with the newer firmware, have a log where you could type in the base. Right? Now whether that's an advantage or not, I don't know. I don't think it is particularly an advantage, right? Because you still have to know how to change the base. And we'll get there in a couple of days. Okay. We're not there yet. Okay, so ln is base e. Log base 1/4 of 64. Okay, so this just going to be evaluate. What does evaluate mean? Come up with a value, right? So come up with the value. So evaluate log base 1/4 of 64. Okay, how are we going to do this? Well, we can start off by saying, I have to evaluate, I'm going to set it equal to something, right? I'm going to let something be equal to. So I'm going to start off by saying, all right, fine. Let's let y equal log base 1/4 of 64. So I ask you to evaluate a log. You just say, all right, I'm going to set it equal to something, and I'm going to solve for y. What's y? It's a logarithm. What's a logarithm? An exponent. And I'm just going to make you say it all together, right? Just all together now, just say a logarithm is an exponent. Okay, so what's the base? So 1/4, what's the exponent? Quarter to the power of y is equal to 64. You could put 4 to the -1, yeah. Okay? So 4 to the -1 to the y is equal to, well, 64 can also be written as a power of 4. Right? So you can write any larger number as a power of a smaller number. You can't go backwards. Right? Like, I think on the quiz somebody tried to write 8 as 64. It's like, I'll just square the 8. Yeah, you can't just do that. You'd have to square both sides, right? Like you change the actual value of something. 4 to the -1 is just a quarter. I haven't changed the value. We're just changing the form we're writing it in. Okay, so this is, what's this? 4 to the -y. Now what? And ultimately, okay, now if you want to check that, you go back here. And you say, let's take 1/4 to the power of -3, hit enter, should see 64. When we learn base change formula, you can actually just do the log base 1/4 of 64, and it'll tell you, okay, what the answer is. Okay, so in this case, y is equal to -3. Okay, which expression has the greater value? I was going to ask 2. I mean, I could see this as a numeric response question where they give you 4 expressions. You evaluate them, and then you put them in order from smallest to largest or from largest to smallest, right? So you actually have to do some evaluation. Okay, I'm going to give 2 expressions. One is log base 2 of 16 plus log base 2 of 2. And B is log base 2 of 1 minus log base 2 of 1/8. So we're going to need to evaluate both of these expressions, right? Say, okay, so what's log base 2 of 16? Or another way to say that is 2 to the power of what is 16? 4, right? 2 to the 4th is 16. What's a logarithm? It's an exponent, right? What exponent? It's the exponent we raise the base 2 to in order to get the number 16, right? You just count on your fingers. 2 to the 1, 2, 4, 8, 16. Okay, so that's equal to 4. 2 to the what gives you 2? 2 to the 1. 4 plus 1 is 5. 2 to the what gives you 1? 0, right? Remember that, right? Log base anything of 1 is going to be 0, right? Remember the graph. It always has an x-intercept of 1, right? Because then the y value is 0. What's the y value? It's the exponent, right? Because a log is an exponent. So log base 2, 1, what exponent? 0. minus, okay, log base 2 of 1/8. I think we did this like a pager, so just look back in your notes. What does that evaluate to? -3. What's 0 minus -3? +3. Which one's bigger? 5 is bigger than 3. Okay. So we evaluated two expressions. Be a good test question, right? You do like 4 different expressions like this and say put them in order. Okay, how many of you have done chemistry? Some smallish number. And not many of you, nobody's doing chemistry this semester, right? Okay, you're all here. Anybody doing chemistry this semester? No. Okay, so the second field test will be arranged for the day of the chem diploma, right? It's not going to interfere. Probably around 10 o'clock. I don't know if I booked it already or not. So in chemistry, what's the thing that uses log? pH, which we shall henceforth refer to as. No, sometimes I'll call it, because what do I care? It's chemistry. So if on the math exam or on a math test I'm going to ask you something to do with, then I'm going to have to give you the formula. The formula for formula for pH, right? We have to tell you what it is, okay? Because not many of you have taken chemistry and nobody's taking it this semester, so it can't be expected to know about pH, right? So then they'll tell you pH. So we've got P of x is negative log x, where x, so we'll go up here, we'll say where x, so you're getting a little box at the top, it's called a context box. And it will say at the top of the box, it will say use the following information to answer the next question. Or could say use the following information to answer the next 2 questions, right? If we give you 2 questions based on something. So you'll get a context box, and they'll explain, right? In chemistry, the pH, P of x is equal to negative log x, where x is the hydrogen ion concentration in moles per liter. All right, so and P of x is the pH, right? And P of x is the F. What's F stand for? Or pH? The power of hydrogen. Right? You didn't know that? Embarrassing. Math teacher has to tell you what pH stands for. So pH stands the power of hydrogen, right? It's about an ion concentration, right? It's hydrogen ion concentration. So the more, now, how's the pH scale go? It's like backwards, right? I mean, lower numbers are what? You go down on the scale, low numbers are acidic and high numbers are basic, right? You basically kind of go from about 0 to 14, where 7 is in the middle. So it's the Switzerland of pH, it's neutral, right? And then you go down, you're more alkaline, you go up, it's more acid. Okay, so the hydrogen ion concentration of a solution is 0.0001 moles per liter. Calculate its pH. All right, so which one of these things is the hydrogen ion concentration? The x. So they've told us x, right? And P of x is the pH. So pH is equal to negative log 0.3 zeros and a 1. So you can really just plug that into your calculator. Hit the negative, which is down at the bottom in brackets, right? Then the log sign. And then 0.0001. And hit enter. And you get 4. So is the solution acidic or basic? It's acidic. right? You're not expected to know that, right? Because if you haven't done chemistry, you would know. So there'll be no questions that rely on you having done chemistry, but there could be questions on pH. Any other famous logarithmic scales you've heard of? Like earthquakes? What scale is that? The Richter scale. What about the one measuring loudness of sound? What do we measure sound in? Decibels, right? So that's also a logarithmic scale, right? We'll go into that more over the next couple of days. How much more acidic is a solution with a F of 1.6 than 1 with a pH of 2.5. Okay, so we have special knowledge because we have people in here who've done chemistry. So we know that 1.6 is more acidic, it's lower, right? The closer you get to 0, the more acidic you get. So it's more acidic than a solution with a pH of 2.5, which is higher. It's still pretty acidic. 2.5 is no slouch on the acidic scale, right? But what's stomach acid? Anybody know pH of stomach acid? 1, 2, or 75. One of those. Well, it's not 7. That's neutral. You wouldn't dissolve anything in your stomach with neutralness. It's 2. Neutrality. Is it 2? It is fairly acidic.
Google it.
Is it? Yeah. I could Google it, but. Okay. Wow, we'll do that in a minute. Well, you can Google it while I'm doing this.
It's in the textbook.
Whatever. Is it? Oh.
There's a page.
Oh, there's a F page. The whole page devoted to F.
What does it say? What does it say? What does it say? What does it say?
It says 1.
1, right?
1.
Good stuff.
Okay, pretty acidic. All right, I'm going to show you 2 ways to solve this problem.
Why is it tough?
The hard way, which you will see and then never use again. And then the easy way, which you will use again. You got to see the hard way because you really should know where this stuff comes from. In case you ever take chemistry, you know, in post-secondary,
Comes from England.
you know, I don't want to. Okay, so we know that pH is negative log x. We are given a pH of 1.6, right? So we know the pH is 1.6, and that's negative log x. That means we can solve for x, right? Now you got an expression. We got a log key on our calculator. Not that we're going to use it, because we don't use it this time. So here's what we're going to do. First of all, the log, you can't work with the negative, so we're going to kick the negative over to the other side. We're going to multiply both sides by negative 1, so I get negative 1.6 is equal to log x. Now you can't solve that, right? Because what are you going to do? Hit the log key and then type x? That's not going to work. Well, technically, I suppose you could, and then you could graph it. Yeah, go ahead. All right, so what you're going to do is change from logarithmic form to exponential form. What's the base? 10. What's the exponent? Negative 1.6. What's that equal to? X, right? So we didn't write the base in there. If you have an unwritten base, what is it? 10. So we know the base is 10. What's a log? It's an exponent. So the exponent is negative 1.6. So x is equal to 10 to the power of negative 1.6. Now, we're going to do the same deal with, all right, I got a pH of 2.5. So negative 2.5 is equal to log x, and 10 to the power of negative 2.5 is x. Now what I want to know is how many times more is one thing than the other, so we're going to divide, right? We're going to divide the more acid, which is the negative 1.6, by the less acid, which is the negative 2.5. So we're going to take 10 to the negative 1.6 divided by 10 to the negative 2.5. Okay, we can do this, right? It's just exponent stuff. What do you do when you're dividing powers with the same base? You subtract the exponents. So 10 to the negative 1.6 minus negative 2.5 is 10 to the power of 0.9, positive 0.9. And what's that work out to? So we can do that on our calculator. So 10 to the power of 0.9, and we get a number less than 10. What is it? 7.94? Okay, let's go with that. So how many times more acidic is a solution with a pH of negative 1.6 than one with a solution, or one with a pH of negative 2.5? 7.94. Okay, that's the hard way, never to be repeated again. Here's the easy way. This applies to all things that have a logarithmic scale, right? So pH is on a logarithmic scale. Decibels, logarithmic scale. Richter scale, logarithmic scale. Anything with a log scale. When you want to find out how many times more intense one thing than the other is, here's what you do. You go 10 to the power of the higher number minus the lower number. Negative 1.6, believe it or not, is actually higher than negative 2.5, right? It's closer to 0, so it's a higher number, to the right. So when you get this problem, you're just going to go 10 to the negative 1.6 minus negative 2.5, which is going to take you to here and then here. You don't have to go through the whole rigmarole of, well, what's the hydrogen ion concentration of this and what's the one with that, right? So if it's earthquake, it's 10 to the power of the difference between the magnitudes. Earthquakes are nice. The bigger they get, the more intense they are, right? As opposed to pH, where the lower it gets, the more acidic it is. Okay. So earthquakes, decibels, actually have to divide by 10, because what's deci mean? Deci is a tenth, right? So a decibel is 1/10 of a bell, named after? Alexander Graham Bell, right? Which is used to measure the loudness of sound. So we measure in decibels. So if I have 100 decibels, it's going to be 10 times louder than 90 decibels, right? Because each one is 1/10. Whereas on the Richter scale, if I have a magnitude of 7, it's 10 times more intense than a magnitude of 6. Okay, we'll get into that more as we do the rest of the stuff. Okay, so for now.